everybody. Welcome to Houdini Hangout. It is August 16th, and it's the week after Siggraph, so we're back at it. Glad to have you with us this evening. I put out a little video the past couple days and was just asking if people were interested in learning a little bit about pyro simulation with burning up some cloth, and I got some really good response to it. So, hey, Ivan, nice to see you. Nice to maybe get your real name. Yeah, I've seen you post around, and we chatted a bit on Discord. Nice to have you on the stream. Welcome. Yeah, so it's the week after Siggraph. There was a lot of great talks there that happened. I think it was 3 days of pretty much jam-packed side effects talks, a few different kind of topics, depending on if it was maybe games related, pipeline related, maybe more art freelance kind of stuff. Lots of different like kind of groupings. I think they even kind of grouped them by day, but there's some really great talks that'll be coming out. So excited for you all to see those on the Side Effects website. Not sure when they'll be, but hopefully in the next couple of weeks. But they were really good, and heard lots of good things about them. I didn't get to sit through a lot of them because unfortunately I had meetings for most of the day. I knew they were recorded, and there's a lot of other things I wanted to see as well. So I got to see a bunch of really cool talks. If you have considered, getting the virtual access to something like Siggraph, I think it's pretty worth it. There was a lot of really cool talks, and I feel like every talk I watched so far has had some mention of Houdini in it, which is obviously very fun for me. But it's cool. It's been a really cool event this year to kind of see what people were talking about. Got to go to some talks about, with USD, excuse me, which were really good as well, to kind of hear where the future of USD is going and kind of what they see as the, where the technology is headed. Probably on quite a bit more of a technical level in some cases than what I normally talk about on this stream, but certainly really interesting. And just got to meet a lot of great people in person and have some good conversations, lots of meetings with educators from around the country, around the world, lots of different places. So really great presentation overall. But I guess to segue that into what I want to talk about tonight, I was watching a Avatar talk from Weta, and I had sort of seen this talk before, not exactly. They talked a little bit about it at FMX this year, and I saw some of that, kind of behind the scenes at that talk. But this time I was looking at it, and I was thinking about, they were showing a scene where, spoiler alerts if you haven't seen it, a scene where they're like flame throwing these like huts, basically these like beachside huts, and they were burned and that type of thing. But as I was watching some of the reference of it, it basically was just like this like canvas stretched on like a like some sort of structure, skeleton type thing to kind of hold it up. And I saw that, and I was like, oh, that's kind of interesting. I feel like you could, I'm sure from what I've seen, a lot of it has Houdini, either actual Houdini's like simulation type stuff that had, off the shelf, or stuff that they've built in Houdini that is custom solvers and things like that. But so I was like, oh, obviously you could do this in Houdini. It'd be pretty fun. I was like, wonder what that would look like and how exactly that would work. And just if I wanted to kind of attack that on a really basic level, like what would that exactly entail? So I was playing around with that a little bit. Actually, the one night after the event, I was in my hotel, and my wife actually came with me. And so I was waiting for her to come back from, I don't know, I think she went to for a walk somewhere. And I was waiting for it to come back, and I'm just like, I'm just going to screw around with this. And like, I actually started to get somewhere a little bit with it. I'm like, okay, I think this is something that can like really be a thing. So that's what we're going to walk through tonight is kind of how would you go about, doing something like this where you're burning cloth, right? Because you have this tricky problem here, right? And I think the interesting thing is that you've got the fire, which is eating away at the cloth, and the cloth is the fuel for the fire. So when the cloth is gone, the fire needs to be gone, right? So you've got this kind of coupled simulation, but there's got to be an easier way to do that than trying to do this multi-solver kind of thing. I mean, this is the kind of stuff that Weta is figuring out, right? That they're doing all these coupled simulations, and the fluid and cloth are all being solved at the same time, and blah blah blah. It's all this super in-depth stuff. But what if we want to do this on a much more basic level? How would we go about doing this? So that's kind of the thing that I wanted to kind of try tonight. And let me just pull up the video that I made here. Hold on a second. And we'll take a look at what this looks like, what I kind of came up with here. So I think this will loop. Let me just see if this is going to loop or not. I think it will. Okay. Yeah, it's looping. Cool. All right. So this is the kind of little video that I posted online. It's definitely not like the highest resolution thing in the world, but I think the concept is there, and you can understand kind of how you would go about doing something like this. There's some things that you could obviously add to this. Like one thing I was thinking about was like, as those individual polys get kind of popped away, instead of having them just like pop, have them kind of turn to like ash or something like that and spread out, like kind of fall. But I haven't tackled that at all. But this was just something I did in I think it was like a couple nights I just played around with it. But anyways, there's also a little weirdness at the beginning there. It's the cloth kind of moves a little too quick for the substeps in this render, but obviously you could up your substeps and have that be a little bit better. But yeah, so this is what I want to kind of walk through tonight. I'm going to do things a little bit differently. I don't want to do like, hey, this is the node to put down, and then put this node down, and then do this parameter. And this is why, like, I want to kind of walk through the process a little bit more rather than trying to build this from scratch. Oh, thanks, Nabil. Yeah, thank you. Appreciate that. I mean, certainly it could be a lot higher like quality, but I think the concept's there, right? Like, I think the idea is there and it's working. The cloth could probably be a higher resolution mesh and blah, blah, blah. But thank you. I appreciate it. So that is kind of what I want to do tonight. So I guess let's just dive in here. Kind of already set up for this kind of a look, but one thing I just want to say too is, which I usually say at every, at every stream, like this. First of all, I'm not like the expert at Houdini or anything like that. I'm just a guy that likes to use Houdini. I do tutorials and courses for my job, and I just really like talking about Houdini. So I'm not the expert, certainly open to hear ideas or thoughts on this process, like how you might do it better, ways to improve it, things like that. So please, if you have any comments, questions, ideas, thoughts, you can drop them in the chat. I'll be kind of monitoring that throughout the night. So if you drop anything in there, I'd be happy to take a look at it, see what you're talking about, and kind of make comments from there and kind of have a little back and forth, because I don't want this just to be me talking at you. That's kind of boring for everybody. So the more we can have back and forth, the better. So that's always something I like to encourage. The other thing I just want to say too is, like, when I show things like this, where it's like, this is a technique for doing this, this isn't the only technique for doing this, right? There are so many ways you can do things in Houdini. Like, this is one of like 100 different ways of doing this. You could do, like I was saying, you could do a coupled sim where the sims are actually talking to each other and trading data back and forth. You could probably do half of these techniques 5 or 6 different ways. So like, all combined, there's probably hundreds of different ways you could do this, right? This is just the way that felt right to me. And I'll kind of explain my thought process as I was going through it and talk a little bit about what was happening as I was kind of walking through this process. It might not be as long of a stream as normal, so I just want to make that caveat as well. Like, I'm not sure how long it's going to take for me to talk through this, but obviously the more questions and comments there are in the chat, like the more we can kind of dive into little bits and pieces that you aren't understanding. So, and if you're not understanding something or missing something, like ask the question, because somebody else is probably missing it as well, and it might be me not doing a great job of explaining it. So yeah, always happy to answer any questions that you might have. So all right, let's dive into it, talk about this process. So I really have a super complicated object network here. I've got two nodes and a camera, so we're really getting in deep here. I basically just split them up by when I was working with the cloth versus when I'm working with the Pyro. The Pyro Sim is the last stage of it because I wanted to have everything mostly driven by an attribute that would be kind of animating along, kind of from some set point on this mesh and animating outward. So let's dive into the cloth first, because that's where, the Pyro just is a few nodes here. There's nothing really too crazy going on here. We'll obviously talk about what I did here and why. But yeah, let's take a look at the cloth, because obviously this is where most everything is happening. Yeah, great question. So you can't watch the stream now, but you'd like to see it later. Yeah, this stream, I'm streaming to both YouTube and Twitch right now. So if you're interested in picking up and watching the stream later, it'll be on YouTube. It's always there when I'm finished. Houdini Hangout, you can search it on there, and there it'll come up. It should be on, I think there's like a section where I have like live videos and things like that. So you should be able to find it nice and easy on there. So Louis, I think maybe, hopefully you'll be able to get it there and watch it later. So yeah, thanks for stopping by though. Anyways, awesome. Yeah, no, you're welcome. Thanks for checking it out regardless. All right, so here's the setup. It's actually not as crazy as you might think. In fact, this whole thing here is actually just now that I'm realizing how messy this is, I usually try to be a little more neat than this, but this is just the actual spreading Pyro, what is it? Sorry. Pyro configure spreading fire. So that network is what I kind of use, because I knew that we had our spreading fire preset, right, in Houdini. I knew that was there. So I was like, okay, that is going to get me a pretty good amount of the way there. I just need to kind of work with this after the fact and like kind of mold that into something that will be usable for me. So I basically took some of this stuff from that setup. So that's why this is here. This doesn't really do a whole lot of anything. This is just basically simulating spread of, this Pyro or whatever. I don't know if this will even be anything. Oh, I don't know why that's so slow. That's weird. Maybe if I do that, there we go. Because it's trying to sim in the background. That's why. Let's see. Is this doing anything? Temperature. There we go. So this is what, the spreading fire like simulation is doing by default. So I'm going to talk about this and what this actual node does. But first, I'll show you my actual setup. Hey, welcome to the stream. I don't know how to say that. Chluade? I don't know. CHL. I don't know how to say that all as one thing. But hey, welcome to the stream. Yo. So what I started off with was a planar patch because I knew this was going to be a Vellum sim eventually. I wanted to, hey, Spider, welcome to the stream. Thanks for joining us. Since I knew this was going to be a Vellum simulation, I was like, well, I'll just start this as a triangulated mesh. I also knew that I was going to be removing polygons from the sim as we go. And I thought, well, most likely if it's a triangulated mesh, that as that breaks up and gets removed, that edge is going to look a lot better. We're not going to be removing these like perfect squares or whatever, quads from our mesh. So this I felt was going to be a much better way of kind of starting this off. And the planar patch tool is really nice. It's got some nice grouping here that you can do. So right here I have some seams that have been created that makes point groups, right? So I have my burning cloth, bottom, left, right, and top all here. And actually something that came in really handy at the end of this is this material UV point attribute. because, well, we'll talk about that a little later, but that ended up being really important, and I didn't even mean for it to. So it's really nice to have that point attribute in here, to have like this UV attribute at the point level, but it isn't my actual UV attribute. It's just this like material UV. So that was really nice to have, and certainly helped me out to have something that was, I mean, I could have done a similar thing with like a rest attribute or whatever, but anyways, you'll see what happens with that a little bit later. So in this node here, basically you can just set your plane, you can set your edge length. I should be able to play around with this a little bit, but like, so if I wanted it a lot denser, I can obviously adjust that right there. And then we've got a way higher resolution mesh. But for my simulation here, I was doing it like this because I didn't really want to go too crazy with it. Also, I think I started on my laptop, so I was like trying to like not make it too overly heavy. So that's the planar patch I have, just a 2x1 rectangle, nothing too crazy. And from there, I wanted to source some Pyro, right? Because ultimately, Pyro these days is sourced from starts as a point cloud, right, with attributes on it. So in this case, we're starting with a Pyro source and we're adding temperature to it. The reason that the other attributes aren't there yet is that those are going to be taken care of by this Pyro source spread, right? So in this case, the Pyro source spread is going to actually be the thing that kind of drives all of our attributes and our points. This is just starting off by giving us some particle separations and scales and scattering it on the surface. This is like a kind of like a fancy scatter node, right? Giving us an interesting scattered value. And this is going to be similar to what we had here in temperature. Actually, I'm not sure why they did it that way. That's interesting. Anyways, this more or less will give you the same thing. The default value of 1 and a scale of 0 is just multiplying it by 0. In this case, my default value, I want it to be 0. And the scale is 1. So I guess it's kind of 6 of one, half a dozen of the other. But anyways, and then here I used a sphere, right? So I wanted to have this sphere that would kind of drive where this fire would spread from, right? I'm just going to click on this here so you can see it. So it might be a little hard to see. Let me turn my points on. So there you go. You can kind of see this blue area here is my sphere. I just wanted a small area where this would start from, right? That's the source of my burn. And so I could move this sphere anywhere, and that's going to adjust where this initial burn point is going to start from, right? So I'm using that to drive this distance from geometry, right? And what's happening here, if we look at this and take a look at our temperature attribute, which is there, and I'm going to turn off these points. So this is what ends up coming out of this distance from geometry node. And it's not super helpful, right? Because we want it to be a small area, right? We don't want it to be this huge area that's coming off of it. There's other ways you could do it as well. You could do it with an attribute transfer node. I mean, there's tons of different ways of doing it. This was just maybe what was in my brain at the time. I mean, you can always do things differently, but this distance from geometry basically is giving us I think this is visualizing a 0 to 1 value, but actually if we look down here, we can see the temperature in this case is going from 1.7 all the way down to basically 0, or as close to 0 as you can get. So I wanted to remap that. We have an attribute remap SOP. So that was important for this. And I wanted to, let me turn temperature back on. So here what I'm doing is I'm taking the input minimum, which is 0, and the maximum, which is I have it like 0.028. And so this is just taking a very small area here and I'm reversing it, right? So that towards the center is 1 and towards the outside is 0. So this just makes a little hotspot there. I mean, like I said, you could do an attribute transfer, but then you have to have attributes on your sphere. So it's kind of 6 to 1, half a dozen the other. It's not really any less or more nodes. So, you can do this multiple different ways. But so I've got this distance from geometry. I've remapped it now so that my output here is just this tiny little hotspot. Pretty much those are the only points that have an attribute of temperature on it, and the rest of them are basically at 0. If we look here, all the rest are at 0. So when this gets fed into this Pyro source spread node, this is going to actually drive that spreading animation. And the reason you're not seeing anything here is because I decided to have the start frame on 12. I wanted the cloth to settle a little bit before it started to spread. So here's what happens. So we can visualize a few different things here. So this is our diffusion, right? So this is kind of how we're pushing our temperature, like how our temperature is changing here. And so this is how it's able to, so this is basically diffusion rate, right? So you can see down here in our diffusion rate, diff rate, that's visualized here. I think it would be better for this to say diffusion rate, but it is the rate of how this is diffusing. So you can see that in higher values here, like red values, it's going to diffuse a lot quicker. In blue values, it's going to diffuse a lot slower. And so we can obviously adjust this here and change kind of how this is working. If we want there to be regions where it diffuses a lot slower, we could certainly lower this quite a bit and then move this over here. And now there's going to be areas where it's going to be, there's only going to be some areas where it goes really, really quick. So if we take, I have this all cached here, so I'm not at cache down here, so I'm not too worried about this. But if we look here just at the total burn, that's kind of your best way to kind of visualize what's happening here. If we watch this, we can see now that there's sections where it's going to diffuse really fast and others where it's like barely going to diffuse at all. So this would make obviously a totally different looking sim, right? And it doesn't go very far, right? Because that diffusion is kind of limited. So the diffusion rate is an attribute that's telling it how quickly it can spread through those areas. And if we look at this end result here, this should match up pretty closely to this shape here. It's not going to be 1-to-1, but you can see kind of some of these shapes here where it's like areas where it allows it to go faster versus areas where it allows it to go slower. So, you know, just something to keep in mind there. I'm just going to undo that to put it back to where it was. That's where it was there. And yep, it's going slow. So if it doesn't recook the cache, you can just reset it there and it'll know. Now this will give us what we had before. We've got this nice spreading value here. It doesn't go all the way to the edge, right? So that diffusion rate is obviously going to really affect how quickly it gets through this whole simulation. And here you can see there's actually a global rate as well. There's also a cooling rate. So there's a few different things here that'll affect how this kind of flame is spreading. But overall, that is kind of the idea of this node, is that it's allowing us to have this attribute that kind of spreads out and we can, you know, simulate how this fire would spread. And this is what's going to drive not only our fire simulation, but also how we're removing geometry from our cloth simulation as it's kind of burning away, right? So that is specifically what's going to be driving that. So this attribute is going to come in really handy for us. And this was why I wanted to use this Pyro source spread, because I don't have to create some sort of spreading simulation. It already exists here. It's already something that works. So a couple other things here. Fuel, we can look at where the fuel is on this. And so this is a combination of the you know, where fuel is for it to burn and things like that. So you can see that certain places here, maybe it's not going to continue moving on. Like right here, it kind of stops. And so it's a combination of the diffusion and the fuel that's going to allow these values to kind of flow through here. And you can see this changing, spreading, like this flame change here. That would be if this was something that like a log that could stay burning and would hold its like temperature and hold itself together for a while and you didn't want it to burn away. This is kind of that sort of like keep alive almost animation that you see on like logs and things like that when they're glowing embers and you see them kind of moving around. And that's what this is supposed to, you know, kind of represent. And you can adjust these noise types here with the duration and all of these here, change the element size of it. So you can obviously change the element sizes here. You can also change the pulse duration, and that's going to change how quickly this is going to kind of evolve around. So now this is a much more like frenetic, kind of frantic noise. And the other thing here too is this injection rate. I actually, I didn't really so the initial fuel makes sense, right? You want the initial fuel at 1. This is how much new new fuel is being injected in there. And then this is basically just saying what the maximum amount of fuel is. So we're not adding anything past 1. So just to make sure basically that things have the fuel it needs to burn away, right? Because you need temperature and fuel to allow it to burn basically. So playing around with those kind of just allowed for those values to kind of fall into a rate, that worked for me. So I don't have any real like crazy insight into those specific attributes here, but hopefully just seeing how some of these things work will give you the understanding of kind of what these things do on a kind of larger scale. And then combustion is again just a simple it's kind of a simple tab. You're basically saying what's the temperature that we're going to ignite at, and then what's the rate that things are going to be burning at, like how quickly are they going to be burning. And again, temperature output and burn output, those are the attributes that are coming out at the end of this. So like when you get the points coming out going into your simulation, what values are those going to be at basically. Animation, I didn't really use any of these. I didn't change any of those. Those are just default. And all I changed here was gave myself a little more just a little more cache just in case I wanted to recook. But that's more or less the Pyro source spread. And the reason I used this was because I didn't want to have to build something from scratch. I knew this was going to be a spreading animation that would feel like fire on some level. And I wanted to kind of go from there and use this as like a base for it. So that was my idea, and that was the idea behind it. So from there, I have another attribute remap here because I wanted to make sure I was clamping the total burn. I actually think I might have solved this without that issue. Let me see here. Where does total burn go? Total burn right there. Yep. Let me see where we get on this. I'll just let this go to the end. Okay, yeah, that's what I was running into, was that the total burn was just going past 1, and I didn't need it to. Like, it didn't need to go to 20 or whatever. Like, I think it's counting kind of continuously, like how long it's burning for, basically, or the amount of burning it's doing kind of a thing. And I didn't want that to be happening, so I just used this to remap that value to just stop at 1. So it's just a clamp, basically, just a really simple clamp, and it's just an attribute remap to kind of clamp those values to 1. And what we're looking at here is this total burn, so that it's keeping that at 1 instead of going past 1. So yeah, so that is just clamping it and nothing really too fancy going on there. So what I then got to the point of was I wanted to start building this Pyro Sim and having this drive it. I'm going to kind of ignore this at first because we'll see why some of this is needed in a second, but I'm just going to kind of skip past it and talk, just about the cloth simulation that's going on down here. So the first thing I started doing here was just setting up a vellum cloth. I didn't need to do anything really complicated with this. I just needed to have this be just a cloth that's pinned on the edges. I have my pinpoints set here with those groups. Those groups were started up on this planar patch here. There's 4 point groups all along the edge. So yeah, it's just using those points to pin the edges. This I'll talk about in a second, this remove frame attribute copy that I'm doing. But the Vellum solver basically goes from there and does a cloth simulation. And there is a little extra in here. I'm just going to turn that off for right now, just so you can see what it looks like without that. But it's just basically the cloth sags down and yeah, nothing too exciting happens here. It just kind of sits there, right? And so what I realized I needed was a way to say when I wanted to remove these polygons from the cloth simulation, right? However, I ran into an issue, and the issue was that I could do it kind of one of two ways. I could set some sort of a threshold at which things would start to delete at, right? Which is fine and could work. But what I ran into was that I needed a very specific way, it would be best to use this in a very specific way to not have to like import because at this point here, right, when you're at this stage here of this Vellum solver, especially in SOPs, once you've this input right here on the Vellum solver only gets calculated at the input, right? It does not get calculated constantly. So I needed a way to be able to bring in the animation of this cloth, for example, and calculate things like where those attributes are moving across it. I needed to be able to transfer that attribute across. Like really one of the attributes I'm bringing across is this total burn here, right? So if I look at my total burn still here, yep, turn that back on, we can see that I've transferred that back over to my mesh. So that total burn is animating through my mesh, which is great. Like that you could use and delete based on that attribute when that attribute hits a certain level. But that includes me bringing in that animated geometry into my simulation. And the way I wanted to do it, that was causing some issues with being able to calculate that. I wanted to do it as simply as possible, and that was causing some issues. And the simple way that I wanted to do that was with this SOP solver. And this is not the most basic SOP solver. If you do a SOP solver here, there's two different ones. This is the SOP solver constraint geometry. And I always wondered what this was for. And now I realize what it's for, and I don't know why it took me so long to realize it. But normally a SOP solver is kind of a way, if you're not familiar with it, that you can come in here, you can mess around with your DOP geometry, you can grab all these different things from simulation, right? We've got DOP geometry, we've got impacts, we've got feedbacks and relationship geometry that we can use to influence our simulation, right? Influence the geometry of our simulation at a SOP level. Right now you can see I'm in a geometry context. So this is all SOPs, right? And then from there it gets ported back out into DOPs, and that data is now part of your simulation, right? Whatever you've tweaked in there is something that's going to run constantly every single frame and be able to update and feed the previous frame in, adjust it, and then move to the next frame, do the same adjustment, next frame, and you keep iterating on that within the simulation environment. So SOP solvers are really nice for just tweaking geometry and stuff like that. However, this has two parallel streams of data that we're working with in here, right? So when we're looking at this here, and we look at this Vellum object, for example, I'm just gonna make this a little bigger for right now. We can see that we have our geometry in here. We also have our constraint geometry. And if you were watching the Vellum, kind of talks that I've been doing recently, you know at this point that Vellum has this standard geometry like this, right? You're just actual geometry. Then it has its constraint geometry, which is way different, and it's all of these kind of polylines that are used to kind of create these relationships between each individual point of the mesh. So if you look at it, we have the same number of points in both of these, which is 17,148, 17,148. Now the primitives are different because in this case the primitives are polygons. In this case, our primitives are constraints. So in this case, we have 101,000 constraints on this mesh. So what we need to do is kind of simultaneously run something on both of those and input them back into the stream of the simulation. And so that's where this SOP solver comes in with the constraint geometry, because if we go inside of it here, it looks a little scarier because it's got this scary yellow block around it. But what it's actually doing is working on both the DOP, the actual standard geometry here on this side, and over here it's working on the constraints. And so these point wrangles are literally just doing the exact same thing. They're just in two separate streams. I think I could probably even make that, maybe a little simpler, but it just was one node. So I'm just going to copy it. But what I'm doing in here is basically, because it has this block, I can't have animated geometry coming in here, because what this is trying to do is basically compile this code all ahead of time. And if you have something that's changing every frame, that can't really be compiled. It's not compilable. So that was something I ran into a problem with. And I'm like, well, this is obviously the most elegant and straightforward solution to do something like this. So let me go back and see what I can do to calculate that so that I don't have to bring my geometry in every single frame just to see if it's crossing some threshold. And what I realized I could do was I could use just another solver, which is basically a SOP solver as well. It's just a solver in SOPs. And I could figure out at what frame the this attribute goes from less than one to 1, and at that frame save that frame number basically. So and there might be a better way of doing this. Maybe there's a node that exists for this. I don't know. This is how I knew to do it and screwed around and got to this point. So if you know of a better way to do this, in the comment in the chat or in the comments on YouTube, I'd love to hear if there's a better way of doing this, but this is what I came up with. So what I did was I created an attribute here called remove frame. And this is what I'm going to look at in my SOP solver when I'm down in my Vellum simulation and see this, when this value is past the current frame, I'll be able to say this is what frame it should be removed at, right? This is when that cloth, that polygon, or this point, I should say, because it's really the points that we're talking about. This is when this point should be removed from the simulation. So this is set as default to -1, value of -1. So at this point we have, we don't have anything in here yet until we get to 12. There we go. So at this point we have our remove frame, which is an integer. It's all -1 right now. So we don't have anything figured out yet. However, at the solver stage, this is where this is kind of going to be where all this stuff happens. So here's our solver. Basically what I want to do is bring in input 1 here. So this is our input. So if I had input 1 and output just connected together, that's just passing straight through. There's nothing special happening there, right? But in this case, I'm taking the remove frame from the previous frame and basically just copying it over it, right? So like I'm just continually copying that in so that it keeps making sure that the previous frame value comes into the current frame. And then down here, what I'm doing is basically saying, getting the current burn. So like, what's the current value of total burn? And in the second input, what's the value of the previous burn? So the previous frame of burn. So I'm looking at those two. And when the current burn is equal to 1, the previous burn is less than 1, that's going to be when we set our remove frame equal to frame. So that's only going to happen at one specific point on this timeline, right? So it's going to be feeding in this -1 in here, right? Feeding in -1, copying it over the input until it hits this stage here where it says, okay, these two if statements have both been satisfied. Now we're going to set frame that equal to frame, right? And then we're going to spit that out. Now the thing is that the previous frame is going to have that value on it. It's going to copy it over here, and it's not ever going to see anything happen here again. So it's never going to have to write that again. So what we're doing at this point here is we have a simulation that's basically just running over this. It's really quick. It doesn't take any time to calculate, right? So if I reset this and just play it, you can see it basically plays in real time. I mean, it goes up to 100, like there's no time to calculate this. It's super quick. But what this is outputting, and I'll show you this, this is just outputting, this might be a little hard to see, but we'll set this remove frame here and we'll turn this on and I'll zoom in here. And you should be able to see that this is going to be this spreading value, right? So it's kind of hard to see, but what this is going to be doing is it's going to set the frame. So in this case, where are we? We're at frame 38. So they're all the current points that are being, basically the burn has completed on those points is now there. So there's 38 right there and there. So then on the next frame, if we go one ahead, we're going to see now all 39 gets added here, and so on and so on and so on. So it's basically just calculating and keeping, the previous values that were in there. So this looks sort of like the exact same thing, except it's storing that frame that kind of burn completes on. So once we hit 1 on our total burn, we're going to remove those points, and that's the frame at which those are going to be removed. So yeah, so that is kind of the idea there. And I'm actually thinking about that. No, this is the best way to do it, because I was going to say you could possibly do it. I was thinking like, oh, could you just, as I'm talking through it, I'm wondering if you could do it where it sees this frame as one and then the next frame as one, and that's where it crosses. Like maybe that's the more accurate, like official end of the burn. But I think this works. This might be a frame early. So maybe the better way to do this would be to add one to the current frame and say that's the actual frame you want to remove it at. I was kind of running into a little issue with that, and I wonder if this would fix it somewhat. But anyways, maybe adding one to that might actually be better. But anyways, we'll continue on. So I've got this whole simulation here now, right? But I don't want it to be I don't want it to be animating. I want it to be static. So throw a time shift in there, set it to the last frame, which is just $F end. And now I've got those attributes across the entire simulation, across the entire timeline. And if I reset this simulation and I'm on this time shift here, it's going to calculate that time shift almost instantaneously again. So like here, I'll just jump up here. I'll reset this. And then if I come down to this time shift here, that just calculated that whole solver. So now this exists and this is all solved, right? So at the very beginning here, we have the values are all, what's happening here? They're all at something different. Why are they all at something different? I can't remember what's the deal there. But I noticed that they were doing some weirdness. So what I wanted to do was, I think what I ended up doing was clamping that somewhere. I thought I did. I think I would want to clamp that. Not sure why that was. I think it was just that I was seeing the solver underneath it. That was what it was. It was showing them both. So this is fine. This is clamping it. Nothing's changing. So then I'm just attribute copying those onto here. And the tricky part here is that this doesn't exist here. There's no points here until we get to this frame. So I actually had to put another time shift in here, and maybe there'd be a better way to do that. But this is where I clamped it, right? Clamped it to the first frame. So 12 now gets clamped all the way forward. So now it exists the whole time. We're all good. All of our attributes are good. So this whole chain right here is basically just to calculate where that animation, kind of how the static part of that, how that simulation is going. And the other thing too to note is that the burn here, this is not actually like freezing this at a specific frame. This is still running $F, but it's clamping to 12 so that all of these previous frames actually have that. So let me just show you what's going on here with the total burn. So if I look at this, it's still here and it's still animating, right? So it just holds frame 12 a little earlier. So there. And it's still animating this total burn because this is saying, yep, we're still going frame by frame, but we're just adding this time clamp in here, which is just making sure that these points exist throughout the whole thing. So you could have that. You could not have it. It's probably not that big of an issue. In fact, it's probably not great to have this burning at the very beginning here, but I kind of felt like it made some sense. So, and then I'm attribute transferring all of this onto the cloth. So here's the animation still, but if I come over here, I can now see that I have my remove frame transferred over. So now each of these has the remove frame on it. And so I think I was trying this for ID. I don't think I ever actually needed it per se because I did something a little different down here, but I never removed it. So I was trying to put an ID on all of the points, but totally not needed. So now I've got my cloth with these static remove frames that are going to be really helpful. And I can come in here into my Vellum solver and I can do this. I'll show you. Let me turn this off. So let's look at this if I don't do this part of it. So if I don't remove the constraints, let's take a look at what this will do. I think you'll see some of the issues here. So it's going to start falling down. Everything's normal. And then it's going to start doing some crazy popping. Oh, it actually just completely exploded. That is probably because I did this a different way earlier. So yep, so that's all working fine. Let me just try this. Let me do a solver. Oops, solver. So if I take this standard one, oops, and just take this. So really all I have to do is just paste this in here. This should work. I'm going to throw this in here. So this is like not going to be doing anything to the constraints. So let's take a look at this here. Yeah, it's really weird because actually it was working before, but I was doing this a different way. I was removing it based on a threshold. And in this case, I think it's just absolutely freaking it out, because what Vellum wants is to always have the same number of points in each of those two streams of geometry I was talking about, in the constraint geometry and in the actual like visible geometry of your mesh. So in this case, it's going to make sure that both of those get removed simultaneously from the simulation. So here we can actually see the constraints being removed. Right here we can see them deleting, and those are going to look a little different than how the actual cloth surface is going to look, because these are the constraints that are holding those points together to act like cloth. And one thing I had to do was actually attribute copy between going between the Vellum geometry here and the constraint geometry. So that's what's happening here. Basically, I'm taking this remove frame from the point, the actual point geometry here, and copying it over to the constraint geometry at this step here. So now I have remove frame. Without this, I have no remove frame. Here, this adds in the remove frame. So that allows both of those streams to now have that attribute. So I'm copying that just from one to the other. Pizark, nice to have you on the stream as well. Glad you're joining us live, and thanks for joining from Brazil. Never been down to South America, but seems like a wonderful place, and thanks for joining. So anyways, what I'm doing here is pretty straightforward. I mean, there's not anything too crazy. I've changed some stuff here as far as density, just to make sure that the cloth had a little bit more weight. If the density was too low, I was finding that it was kind of bouncing all over the place when those were getting deleted. And also here with the stretch, tweaking that damping ratio also helped a little bit with, actually both the damping ratio here and here helped with keeping it from, when those get removed, it would almost like ripple through the cloth. So kind of just damping that down a little bit would make sure that it would stay a little more settled the whole time. So I used that to help, that stuff kind of settle out. And the constraint iterations are a little high here. So that might be a little crazy. And I actually just saw somebody talking about this with collision passes. I wonder how much quicker this is with lower collision passes. Just out of curiosity. Hello? Oh, that's funny. Why am I seeing that? I might have a little viewport funk going on here. Let's try this. There we go. Just going to save that again. Let me just see how... Yeah, it might be faster. I just saw somebody mentioning that these collision passes, if you lower them, it can help speed things up a little bit. I just saw somebody talking about that today. I don't know. I haven't really played around with that, so I don't want to mess with that too much. But these were the kind of the values that I found helpful. You might be able to turn the constraint iterations down, and certainly if you have a higher resolution cloth, you'll want to turn the substeps up a little bit. So your mileage may vary, but that's kind of the idea there. And then I just cashed it out. So I mean, really, this is kind of the beautiful thing about something like Vellum, is that as long as you're keeping all of those point counts equal between them, and that's where that SOP solver with the constraint option, that's where that comes in really handy, because it allows you to, in parallel, do both of those things at the same time. Now, they do have to be compilable, quote unquote. So if you ever see a node that has like this mark in it right here, this is not a compilable node right here. So basically that just means that it's not something that can be like boiled down to a code block that can be executed, right? Because there's something in there that's changing with time, or that has a reference to something outside of itself that has to calculate. So there's some weird things like that you'll see. But if you ever see like that compiled block and it's thrown an error, you see this little symbol, that's what it is. So cool. So that was kind of the idea of the cloth, right? Now I know that I have this cloth that's reacting to this burning, kind of spreading pyro simulation. And from there, I should be able to then get my pyro source back onto the geometry. However, I ran into some definite issues with that. It wasn't terrible, but it definitely was something that tripped me up a little bit. So what I would have normally thought, and I knew that with this changing geometry was going to be a little bit weird, but I was thinking like, okay, maybe I can do something like a point deform. A lot of times this is what I'll use, is something like a point deform. And I want to use this cloth. So I've got my pyro points up here. These are the points that are going to source my pyro. And say I have my animated cloth and I want to put that, or no, sorry, I'll do this the other way. I want this to be my mesh to deform. These points are going to be what I deform, and I need a rest lattice here, right? So if I do a time shift again and just get a rest, I'm just going to delete this. Here's my animated cloth. It's just in a rest pose, right? So that's going to go into here. And then my other animated cloth is going to go in there. That's my animated or my deformed point lattice, right? So you know, you would think that this would work. And at first it does, right? It does its thing. But then as it starts to get deleted, we go haywire here, right? Because what's happening is it has points and it has, it has points that it's looking to deform based on that are being removed. And so it can't find those points anymore, but it still has that weighting in there. And what you can do is you can uncheck this delete capture attributes to see a little bit better of what's happening in here. So if we go to here, we can see the capture points, right? And we have the capture point weights. So these are the points and the weights that these points are looking to as this deforming mesh is kind of jiggling all over the place. And when it can't find those, it's like, I can't find that specific point on this, rest mesh and on this animated mesh. So I'm just going to, I'm going to the origin, or that's going to be where I'm going to try to blend between. So you can see how these are all kind of like starting to blend pretty much towards origin, with a little bit of offset from some of the other points that are existing still in the simulation. But that's why it's kind of pulling towards this kind of 0 point here. So I was like, okay, that's interesting. That's not going to work. So then I was like, okay, what if I remove the points before they need to deform, right? I was like, oh, that could work. That could work. So I took this, dropped this in here, and it's maybe a little better, but it's still freaking out. And then I was like, okay, what if I have this like a really low number of points? Like it only is looking for 1 point, right? Something like this, where I'm like super, super low. In fact, I don't know if I ever tried this. Like, it sort of works. No, but well, here it's actually really funny because it's like, you see them going away and it's kind of falling off and stuff, and everything's sort of working. But you actually get this little ball that starts to exist right at origin, which I think is kind of funny. It's like making a little like black hole there. So that's not totally working. So that's not great. And then I tried it with the removing the points first. And again, it's sort of still working, but we're still getting this little jumble of points at the origin. So I'm like, okay, there's got to be a better way of doing this, because this is not working. This point deform, this is not working. And so I was like, okay, what can we do here? So I started thinking about a little bit of, what could I do in Vex? Like, what could I do with a little bit of code that would, pull up, let's just say the current position of where, I'll turn this this animated cloth on here. Like, how can I find that this point here should be attached to a certain spot on this primitive here, right? How can I find that? So I was trying to figure that out. And what I then realized was, hold on a second. If you remember, we have this UV property up here that I'd already worked with. And in fact, I could have done this probably with a vertex or whatever. I could have done this a bunch of different ways. But I have this material UV that's existing on this planar patch. So I was like, wait a second, that could be something great. And I thought about it. I'm like, wait a second, this is actually going to be something that's going to show in UV space. So if I go to my UV viewport, this is what it looks like in the UV viewport. If I look at this specifically, turn this off because it's going to freak it out a little bit. So, okay. So there's my burning cloth, right? Okay. It's all in UV space. But then if I come down here to my points and look at them, where are they? Oh, I thought they would show up in UV space. No, they're not. Why are they not? They should. Oh, hold on a second. Yeah, they are. You just don't see them in here because it's not showing the points. I see. So at this stage, it is showing them. You just don't see it. So, okay. So my points are in UV space as well. Can you see those? No, you can't. That's really weird. So I'm like, okay. So my points are in this UV space and my mesh is in this UV space. So if I look up the UV coordinate of this point right here, it should match up. This should match up to a interpolation of these UV points here that exist. So I should be able to find this based on the interpolation between these. So I was like, okay, I think I've got something here. I think this is going to make sense because I was running into a lot of problems here. So, okay, I'm going to stick on with this remove old points and it's going to slowly remove them right here in our 2D kind of UV space. But then what I'm going to do here is I'm going to look up, I'm going to use this UV sample. And what this UV sample is going to do is it's going to look at this first input coming in here, which is our animated cloth, right? It's going to sample based on the, it's going to sample the position. This is what it's sampling based on the material UV attribute. And it's going to use the current material UV from this input here. So from input 1. So it's going to use its material UV to look up this material UV on the mesh and then return the actual position in space for that. And then I'm going to take this current position and just set these point positions equal to it. So I know that might be a little bit complicated, but let's just go back here, look at the perspective. And so at this point now, these are going to really nicely stay on the mesh. But even more interestingly, I think what happens here is that anything that can't resolve that stays on the edge of this instead of, just shooting up to, origin in space or anything like that. It just kind of makes a little border here, right? So it stays really clean to the actual mesh that's existing here. So if we look at this mesh, we'll see that these are remaining incredibly faithful to what, that mesh is going to look like. So we can see that those points are going to stay really accurately to that. And in fact, I think I have a little bit of discontinuity here because I think something changed on my burning cloth mesh to this. I must have changed something there, but interesting. I must have set something a little differently here. Oh, that stinks. It's gotten a little off kilter. Oh, I know what I can do. I have this saved somewhere else and I can pull that up. Let me do that actually real quick before we go any further. I'll go. Sorry. All right, here we go. I'll just save it. We'll open this. Yes. Okay. So this should match up better. Sorry, give me 1 second. My whole thing is going to reset and try to change to 2 screens because I have 2 screens. No, that's what I want. Cool. All right, let's look at this again. I think we should have a better thing going on here. Let's just check. Okay, simulation. Yep. Everything's going here. What? I hope you're not talking about me because that's very strange. I'm just talking through what I did here. So hopefully this is not anything too crazy. It doesn't think it is a fairly straightforward workflow, hopefully. And I think this will match up a lot better. Yes, it does. Hooray. Whatever property I set back there is acting a little funny. So here we go. So we've got our point cloud, right? It's all kind of staying synced up to this mesh. Now this is just my cached out data. And in fact, I should have cached this out, these pyro points up here as well. Would have been smart, but I didn't. So here we are. Okay, so we've got these points now sitting on this mesh really nicely. And that was something that tripped me up for quite a while. Like it was hard to kind of get to that point where I was like, okay, how do I have these sit nicely on this mesh? And since we have these set up now, if we look at this here, we should be able to see that we have stuff like burn. So that's where the burn is going to be happening now, right? So here's our burn attribute, right? So that red is going to be the highest area of burn in our simulation, right? So those animated points are now stuck back onto that simulated mesh, right? So that is like kind of this little bit of the secret sauce that I think you can do with something like Houdini, where you can kind of mix these different things together, right? You can take one simulation and kind of stick your geometry from another quasi simulation to that, and then put that into its own simulation, into a kind of a third simulation, I guess. But I just love watching this. I think it just looks super fun. And I think if you were going to do this a little bit further, you could certainly get some like little threads that you could pull through. Like if 2 points are like you could do this in your, like from your Vellum solver output, like if 2 points are connected to each other via a constraint, like if we look at this here, we can see that there's constraints that are connecting like these 2 points right here, right? So we have this cloth where there's there's 2 points right there. And we can see that there are constraints connecting them. So if 2 points are still connected by a constraint, just draw a line between them basically, or something to that effect. You could probably come up with some sort of logic that would be able to run off of that and create little threads based on where these things are kind of burning apart from. So, that's something to keep that you could do, or you could do the vice versa where you just delete those kind of random points that are sitting by themselves, which you could actually do pretty easily with like a clean node maybe. That should remove unused points. Let's see. Yes, that did it. I don't know if it'd do anything else weird, but that could certainly get rid of those weird little like hanging Chad points. 2000 reference for those of you that know about American politics. So that would be a way to clean it as well, using a clean node. So anyways, so we're using this, attaching the points of the cloth that brings through all of our, attributes like temperature and burn and fuel and all the things that, I actually don't know if total burn doesn't really do anything in the simulation that I can think of. We also have our remove frame in there if we wanted, and distance. Maybe I had that from before. I don't think we actually have distance in there anywhere, but anyway, so we've got our out animated pyro points now. So we've got our cloth, which is coming out through this output here. I just dropped an output down because I wanted it always to return this cloth output when I'm up at the object level. It's always a good thing to do. Oops, it's trying to simulate that fire. So it's always a good thing to do if you want something to always come out into your object level and not listen to your display flag, right? So that is the whole of kind of the bulk of this simulation, really, in this technique that I played around with, whatever. And I think the next thing really to do here is to put a pyro sim on top of this. And so this is like super basic, basically just merge in those pyro points. And then if you were following along here, we can see basically that actually I got rid of that here. I think I might have actually just grabbed that rasterize from there, but Yeah, I think, oh, excuse me. Whew. I might have just grabbed this from there. I don't really remember now. But anyways, this volume rasterized attributes is basically just taking our points here, looking at the attributes on them, in this case, burn and temperature, and rasterizing those to a volume. So now we have two volumes here, burn and temperature. If we middle click on this, we can see that we have two volumes here, burn and temperature. And these are going to be VDBs. They're blue. I believe standard Houdini volumes are green. And so these are going to be what sources into our Pyro Solver. So we can see these kind of move as we go around here. You know, they're going to be spreading and doing all that kind of stuff. And temperature, I'm actually kind of surprised that the temperature is as big as it is. I'm not sure why that is. But anyways, the this volume rasterized attributes is basically allowing you to to do that, right? It's allowing you to take those points and rasterize those into a volume. You're not seeing them here, but they certainly are here. So they exist. And so that you just pipe in your first port of your Pyro Solver. And when I first started doing this, I was like, oh, you know what? I'm going to have to bring in the cloth itself to make it as a collision object and yada, yada, yada. But I really didn't find that was, I mean, I actually don't have it colliding at all in there, and it might just be the camera angle that you're at. You might, results may vary, but I ended up just saying, like, it was taking a little bit more time to sim with that. I'm like, it doesn't really seem like it's doing a whole lot. So I just took it out. But you could basically bring in your cloth kind of the same way. You could do just do an object merge here. We'll just say get cloth. And then we'll just merge in. I always want to click this these days. I don't know why. I keep doing that by accident. So we'll sim cloth. We'll grab the animated cloth out right here. So this is our animated cloth. And then you probably just would want to pass this through something like a Vellum post process. And what this is going to do is basically, you can do a few different things with it. You could subdivide it, but I found that was doing some weird stuff, I think. Yeah, I was smoothing it out in ways I didn't really want it to. So I was like, I don't want to do that. I think the Catmull Clark makes terrible shapes. You would really want it to be more of a loop, I think, because it's triangulated. But anyways, what I would do with it here is extrude it by thickness. So this will actually make it into a thicker cloth, right? So this takes the thickness attribute from the simulation and turns it into cloth based on that. And then you can do something like a, collision source. And you could just take this out and just put this right into, so you take your collision geometry and your VDB and just basically, I think if you just do this, that would more or less give you your collision. However, this is going to be a really low resolution, mesh or SDF. So yeah, like you can see there, it's like super low resolution, and that's already like quite a few voxels. So I was playing around with it and it just felt like it was taking way too long with that. So I'm like, you could do it if you wanted to, but take it for whatever it's worth. I didn't do it. So we'll just disconnect this. But I had this actually sitting in here the whole time, and then I deleted it before the stream. But let's take a look at this Pyro Solver. So what we're doing in here is we want this, like, I'll talk through like kind of the logic of this, because we talked a little bit about the Pyro Solver, I think 2 weeks ago, with kind of a, it was like a viscous smoke. Hold on a second. I'm just going to grab a drink. But this is a little bit different, so maybe walking through this will be good. I actually changed this velocity voxel scale. This just basically lowers the resolution of the velocity vectors, the voxels for the velocity. Just helps it simulate a little bit quicker, but nothing too crazy. I limited the bounds to maximum size. If you hit enter to go into your view state, You can draw a box around this and make sure it doesn't get bigger. I basically set it to the width of the cloth, but that could actually be a lot smaller. And in fact, it never really went outside of this, so I didn't really find that to be very beneficial, but whatever, I did that. I also lowered the, yeah, exactly. Yep. By default, oh, I think I should have had this on actually, STF and volume velocity. Interesting. Well, anyways, yes. The SOP Pyro Solver will see the source collision by default. So yeah, 100%. I actually, now that I'm thinking about this, I may have had that in a really dumb mode. So that might have been why I was going slow. So actually, I think if you just take this volume collision here, the VDB, because this is our collision geometry. I think if you just take this actually could work as well. Yeah, that does actually seem to be working, and it's not going, it doesn't seem like it's going insanely slow. But yeah, that's certainly how you do it. And yeah, so I don't know how to say your name. I'll say Showrooks. I don't know, but welcome to the stream. On top of that, I don't recognize your name, but yes, it'll see the collision by default. There's settings here for offset and scale and activation stuff. So this is activated and it's working. So if you have something coming in there, it's going to see the collision basically. So the one thing here with the resizing is tweaking this padding value. I think what's it at default? Oh, it's at 0.3 by default. I mean, that's way too big. Like, it does not need to be that big. So I set it to 0.05 just to give it a tighter bound around the simulation. It felt so huge as it was, and it was like, man, I don't think I need that much extra bounding around my simulation. It's just extra stuff that I'm calculating that I don't need to be. So that was something I changed. So sourcing, this I think is sort of like if you do one of like the more basic like configure setups, this is how the sourcing works. But what I did was I actually tweaked the scale a little bit just to show you like it's 2 and 3. So I had this would be at 1 by default. And if we watch how this kind of evolves here, maybe I'll turn the cloth off so we can see it. And let me change this to gray maybe. Sure. So if we see this, we'll see, this kind of shows us like where it was at level 1 and like at a scale of 1. And it felt like it just was a little lacking. Like just didn't feel like it was hitting kind of the intensity that I wanted it to. It felt flat, didn't feel like much of anything. So that's why I upped it. Well, here, you know what? Let me do a quick little flip book of this. Let's go to the camera. I have a camera, so let's do this real quick. I don't know. Maybe I'll do like a few more frames, but we'll let this go. You can kind of see. Maybe I'll go up to like 72 or something. But these are the settings that this I think is by default for a lot of the configure pyro blah 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 whatever. I'll just halt this at 72. Done. Enough. Okay, so there's kind of that. And then if I change these back, there we go. 3 and 2. Turn this off. Cool. Let's make a new viewer and go. So I think you'll see that this is going to be quite a bit more active. We're going to not only get some more flame out of it, we'll also get a little bit more smoke coming off the top. It might be a little hard to see with this gray background, but I think you'll see the flame a little bit better this way. So, whatever. But let's do this. Let's do compare images, and we can slide this over here, and we can kind of see the difference right there. Pretty stark difference. So that is the difference that we're seeing between this kind of just level 1 pyro coming in, or scale of 1, and upping those scales a little bit. So we're just multiplying it to give it a bit more energy coming in, a little bit higher values in those voxels as they come in. So that was, I thought, something that was really going to kind of push the look of the simulation forward a little bit. And what we should do too, actually, now that I'm thinking of it, is look at it through this Pyro Bake volume, because this is where a lot of the really fun stuff happens. This is where it really starts to look like fire and actually does some nice looking stuff. So let me see. Let me go back to the light background. Yeah. So anyways, that's what we got going on here. Let's see. We'll go to gray. Yeah, so it's just kind of enhancing some of the density stuff and things like that. So we can talk about this a little bit more as well. So cool. So then fields, I didn't really have to do too much in here. I think what I did was I admitted the density from the flames. So wherever the flame field exists, I think here we can look at this and see the flame field. Where does that show up? There it is. So this is actually our flame field. You can see a visualization of it here. It's a little light, but this will show you different fields here. Like there's density, there's temperature, speed. If you have your speed field, that's so light. Why is it so light? Can I see this in any version? No, let me see if I do dark. Can I see this at all? Sheesh, barely there. There we go. We'll just compute the range like this. Oh, I see. It's just, yeah, it's being a little bit finicky. Okay, we'll keep this gray. That'll be fine. So anyways, here's temperature, so flame. So wherever this flame is existing, that is kind of where this is emitting from, right? So we're going to emit density, which is going to be our smoke from this flame. And we could certainly go further with this too. Like, I mean, you don't want it to be super dark, but if you went up to 3 or something like this and let this come out, actually, I'm going to turn this off. We'll say no guides. What we're going to have is a lot more density coming out of the top of this here, a lot more smoke and like sooty. So if you wanted a more sooty look to it, you could do that, and it'll have a lot more kind of smoke coming out of the top of it from the flame. So anyways, I'm going to set that back to 1. You can also change where in the flame range it's emitting from, that type of stuff. So that was something I changed. I also changed the speed down here. I added a speed field. And if you're not familiar with why you would want a speed field, it's basically taking your velocity, right, and calculating the length of the vector for each voxel and then saving that in just like a float, VDB or in a volume. So it's storing each voxel a float value of the length of your velocity. So that's your speed, right? So what you can then do with that is in this next field here under shape, you can adjust your disturbance. So normally it just goes by this threshold flame like this, and the control field is off. So I think these are all pretty much the default values that I had in here, because this Pyro Solver might have come from that spreading flame, because I was like, well, I still want to do a spreading flame, so I might as well just use the same preset and see where I start out here. And what you're going to see is this kind of explosion, this like sparkly looking thing. And whenever you see that, I think your first kind of gut reaction should be, oh no, my disturbance is up too high, because what's happening here is it's trying to disturb based on this flame field, and it's just creating this choppy, crazy mess. It just looks horrible. It's so terrible looking. Like no fire looks like this. You know what I mean? Like it just looks crazy. No matter what you're visualizing it through, it just looks absolutely nuts. So this is no good. So what I like to do is, and I learned this from applied Houdini, is using the speed as a control field, and you can set up your control range. So what this basically means is that from the speed of 0.5 to 5, we're going to remap kind of our influence of this disturbance. So when the speed is 0.05 and below, it's not going to have any disturbance on it. So any slow moving kind of stuff is going to be really basically getting no disturbance. Because once something settles and kind of comes to rest, you don't want it to be just disturbing like crazy. So it's basically, as it gets closer and closer to zero, it's basically going to have no interaction with disturbance. It's not going to be trying to push it around and like chop it up. But when it's high, when you have high speed, like in this case 5, now I think this actually gets up to around 8 or 9 at its highest velocities, its highest speeds. That is where you want it to really disturb it. So in this case, at 5, it's going to actually be really disturbing it. So anything that's moving really quickly, like the front of these bursts here, are going to be getting disturbed and kind of chopped up. But as it comes to rest and kind of slows down, it's going to be disturbed less and less and less. So that is what we're doing there. And the shredding also is just helping to kind of break up this kind of flame look. So that was really the only things that are happening in there that are off away from normal. And then look, this stuff is just, if you want to have the look from your Pyro Solver, this is just a way to kind of visualize it. You can just turn that off and this should still work just fine. This is just really for visualization. So if you wanted to visualize just the smoke, there you can see just the smoke. If you want to see just the fire, there's the fire. You can also assign a material here. You don't have to. You can also bind certain volumes to, to your visualization. But anything I do here should have literally no bearing on that. Like none of this should do anything for this pyro bake volume because at the end of the day, this is taking all of the volumes that are coming out of here, which if we look at this, we still have volumes coming out. I'll slide this up. We can see we have all these different volumes here. If you middle click, we have all of these right here. They're standard volumes. And that is what the pyro bake volume is going to look at and kind of shape your the style of your pyro based on that. If we look at the output, this is also important here. This is what's getting output. So you might not need speed being output. Like you could turn that off probably, but I just added it just to see it, to make sure that it was coming out and doing what I kind of wanted it to. You can also convert these to VDBs coming out of there. That's going to be a bit more efficient if you're caching it to disk, so I highly recommend that. But yeah, other than that, that's kind of how this works. Here's a vector VDB. So like in this case, basically what this is doing is it's making sure that velocity is going to be a vector and is not going to be saved out. I think when this is off, it will be saved as an X, Y, and Z vector. You could, I think if you convert it to VDB, take this out. Nope. Never mind. I thought that might work, but it didn't. Anyways, so these are just basically controlling how things come out. You could resample your velocity volume if you wanted to make the size a little bit smaller. This is going to takes it down to 115,000 versus 876,000. So you can change that voxel size scale for velocity on your export if you wanted to. You might not need the crazy high resolution of your velocity field for whatever you might be doing after your Pyro Solver. Ugh, excuse me. But this pyro bake volume is kind of the really fun newer thing that's been added into Houdini as far as allowing you to adjust some of these values a little bit more interactively. So in this case, we have our smoke, and we can see that that's going to add density into our smoke. If we want to get really thick, dark smoke, you could do something like this. It looks ridiculous because that's not really what's going on in the simulation. But anyways, so you can adjust, all these different parameters here and change the smoke color. If you wanted it to be a much darker smoke, you could set it to black or whatever, and then your density is going to even affect it more. So, but something in this kind of mid gray kind of color, I think looks fine. Scatter is kind of interesting. I'll talk about that in a second, but fire is a pretty obvious thing. I'm actually going to turn scatter off. So fire is really obvious. It's just the fire, and you can control how the intensity ramps in it and things like that. So you could certainly have it only be in certain really high, like hot spots like this. So maybe you just want your fire like that to come out, and then you have your density for the rest of it. You know, you could keep it linear like we had it before and just have it go all the way through. You know, it's kind of up to you how you want to shape your flame and your fire and stuff. But, you know, maybe something like that's better, you know, just cut off a little bit of the top end of that just to make it feel a little more fiery. I don't know. But the real interesting thing, I think, hello, stop sending. Thank you. I think the real interesting thing that happens with this node is the scatter. So what you can actually do is have your pyro, your flame kind of intensity scatter through this. So what we're going to see is like this is our density here. And if we look at, let's just change this again, keep changing the background to light. We can see that this is dark here in this case, right? So it's all just dark. But what we could do is add in this intensity, and what it's going to do is kind of push some of that flame color through our smoke, right? So if we go back to 250, and maybe if we just take this out here, we can see that that is going to kind of blend through this flame here. So kind of interesting. You can set this based on a source range from your what is this based on? Is this on the sorry, I'm just thinking of what this is. Oh, right. Scatter is bound to temperature, it looks like. So these are the bindings for each of these, right? So what is this basically binding to within this node? So it's looking at the temperature here in this case. This one's looking at density. This one's also looking at temperature for the fire intensity. You can change these obviously, but so here what's happening is it's blurring. It's actually taking this value and kind of blurring it through using certain steps and using iterations for it basically. So this will, it'll blur more or less based on this radius, and the iterations will help blur it more or less as well. This downsample, I don't remember if this was always here or whatever. The one thing that you'll see a lot of times is this masking, and basically that just means that if there's density kind of in front of your scatter, it'll help mask it out so it doesn't try to push through and make the whole thing bright, but it can keep certain density, it'll keep some of your density in front of it. So that's what this masking is usually about. If we look at you see here the mask volume is density, here's the mask volume is density, that kind of thing. So this is one of the cooler little things that you can set up on here. And when you get to the output here, you can also set the bake emission volume. And what this is actually going to do is make a volume that bakes all of these color values that you're seeing into a volume. So if you want this to just have an emission volume and not have to rebuild this in, any random shader, you can just reference this CE volume in, say, Solaris or something like that, and have that come in, and that's kind of the colors that it's going to be pulling from. You don't have to really overly worry about setting all these things up in there. Again, now I'm sure in future versions of Houdini, as things become more mature with Karma and Karma XPU, there might even be an updated version of how this will all kind of flow through into Solaris. But for right now, you can certainly use this emission volume, and that will give you, I think that's a vector, right? That's a vector. Yep. That is a vector color value basically that you could use to as your emission channel in your pyro shader of choice, whatever you might be using. So that could be used for Karma, or it could be used for Redshift, or it could be used for V-Ray or whatever. It's just a volume that you can read in and use that data. So that's a way you can bake that, bake an emission volume. But yeah, other than that, that's pretty much it. I mean, we've got our, it's not showing up there, but if we look at our cloth here, we can see that's all doing its thing. So, and this is pretty much, where I had saved this out. And, this is the video that I put online. So that's pretty much it. I don't know if anybody has any questions or thoughts based on that. It's been a little quiet in here today, but that's cool. I mean, if you guys don't have questions, that's okay. But I'm happy to walk through something more specifically if there's a question that you might have about something in here. Or if you're like, oh, this feels crazy, I'm not really sure exactly what X, Y, or Z thing was, happy to kind of talk through that and see if we can't make sense of that for you. But otherwise, that's really all I wanted to show tonight. So yeah, so please, if you have questions or thoughts, comments, corrections, ideas, anything, feel free to drop it in the chat. But I'll just let this sim in the background for a second while you're thinking, or maybe forming a question. Well, I'm going to I guess take that as everybody's feeling good about this, like it was well described by me, and it all makes sense. But yeah, I think this is a fun little example of not trying to do too much in one single step. You know, if I tried to do all of these separate solving all these separate problems in one place, in one simulation, I think it would have been really difficult and possibly would have not come out nearly as good, because I would have had all of these things I was trying to juggle at the same time. I think sometimes isolating these steps is a really strong way of going about working, as long as that you know that you can get the data out and be able to kind of push that into the next step that you want to do. That's kind of the main kind of crux of this idea here, right? And I think when I talked to Mark Fancher earlier this year, and he was talking about some of the stuff he did for XFL, he talked about some of these ideas too, where he's trying to, you know, kind of more compartmentalizing these steps, right? So that you're not specifically, say, dealing with, you know, having your cloth and your pyro trying to work together in some sort of coupled manner, and just kind of allowing your cloth to be driven by something like an attribute that exists on the cloth, and removing it based on something that you know is going to then be able to be moved right into your pyro simulation, like all of our points that we kind of started with that spreading, spreading pyro. So I think those ideas are kind of the main concept here that I wanted to kind of play around with, because I figured it was possible. Wasn't sure how good the end result would be, but I was happy with it. I thought it turned out pretty good. And I think you could, again, push this result to higher resolutions. I mean, this is simming while I'm sitting here, you know what I mean, for a pyro simulation. But these can be huge. And the cloth simulation doesn't take long at all. It maybe takes like 5 minutes, 10 minutes, something like that. I just wasn't, wanting to do a, 45-minute sim on the cloth or anything like that. So not that it should, but I didn't want to have anything overly complicated that I was doing for the cloth, so I kept it pretty low res. But the higher resolution you use for the cloth, the better that this outcome would be from the cloth standpoint. So so yeah, I guess that's where we'll end it for the evening, unless anybody has any last minute thoughts or questions. But hopefully this was helpful and interesting. I know a lot of people on Twitter were responding to it, and that was hopeful and exciting. So I'll certainly be posting this back on there just to Yes, for sure. Rendering it in XPU would certainly be very fun. I did not get to that stage yet. I mean, I guess really all I'm going to do to render it, if I was going to render this, I guess I'll just show you what I would do. Because it shouldn't be all that difficult. Is I would do let's see here. Let's do this. Sure, you gave me a challenge. I'll see if I can do it. just call this Solaris. We'll go inside, and I need my Solaris scene graph tree. Sure. That should be enough. Yeah, that should be fine for right now. All right, so I'll just do a SOP import for my cloth. Here. There's my animated cloth. Let's see if that came in right. Yep, looks like it's all good. Animating wonderfully. Great. Then I will SOP import. Actually, I'm just going to call this cloth. This one's going to be Pyro, I guess. All right, so this is going to be cloth. I'm going to put this into my, I'll just call this scene geo. So I'm just adding a prefix there to put it into a little group. And I'll do the same thing here. Oh, Beacans, glad to have you with us. Yeah, great. Glad that you saw the post on Twitter. That's fantastic. Well, it's not Twitter anymore. It's X. Is anyone actually calling it that? Or have we agreed to just ignore that? I don't know what the story is there, but hold on. Let me just jump up here. The reason I made a lop network like this is because I can just use U to jump up and down. Kind of like that a little better. Let me just say no. And we'll just say Pyro. I'll just say out Pyro. And I guess I'll bake that because that should be good to have. I said it would be good, so maybe it'll be good. All right, so we've got our Pyro here. Let's make sure we've got this coming in. Yep. Okay, so scene graph tree, important here. We've got our cloth, we've got our mesh 0. Volume is coming in. Basically what this does is just brings in these VDBs by default. So I should, yep, there we go. Got a VDB in here. I mean, honestly, it's so easy. Like Solaris is not something that should be scary to you. Like this took 2 seconds and I have my scene in here. And then if I do a material library, let's drop this down. And this is the part that is still a little funky. So I'm going to do a Karma material X subnet for the cloth. I'll just call this cloth. And we'll do I'm just going to remove this, do a standard surface here instead. This is like always what I do. I'm just going to leave it as it. Well, maybe I'll just change the color. I don't know. Let's make it blue. I don't know. Sure. It'll be blue. Super exciting. Never seen anything as cool as blue cloth. And then we'll do a material assign material. Got that mixed up. And oh, right. Need my Pyro shader. So there is a Pyro preview. This is the only thing that works with XPU right now. So kind of fun. It's fun. Actually, you know what? This should be totally fine. I don't think we even need to worry about this at all. We're just going to, I don't even think we need to worry about CE. I don't think it's going to matter, but we'll see in a second. But anyways, we'll just say Pyro. So we got cloth and Pyro. So those have both been added into our scene graph tree under materials here. So we've got our scene geo and we've got our materials. We're just going to use our assigned material now. We're going to do 2 assignments. We're going to grab cloth here. And we're going to do the material cloth. And then here we're going to do, I think we want to grab volume 0, I think. I may be wrong. And we'll put Pyro in there. Cool, we've got blue and that doesn't seem to be working. Does it show up in the viewport? I can't remember. Let's see if I turn on Karma. Yes, it's working great. Everything's working great. What if I do this and... Oh, right. That's the problem. I had these at 0. That's the problem. I'm just going to match these up. So this should be at 15. Scatter should be at 250. And then fire, good Lord, what was fire at? I'm just going to match these. Fire was at 250 as well. I figured that should be easier than it than it was. I was like, what the heck's going on here? Sure. Oh, it's like a glossy cloth. That's fun. Let's add some more. Oh, right, the smoke color. Sure, whatever. Mid-gray, something like that. I don't know. That's great. And just for the record, this is not XPU that I'm working with right now. This is CPU. I always, anyways, it's not a very big scene, but I think CPU is a little underrated because it's not bad. Anyways, we could certainly play around with this a little bit. Maybe the fire's a little too hot. You know, whatever. Maybe we do actually want this a little more dense. Something like that. Cool. And then we could just grab a dome light. Gonna throw that here. Let's grab a texture for it. Our basic HDRI. This one should be fine. Actually, that one, I'm not thrilled with that. Nope, too bright. I'm just going to go to my resources, HDRI. Sorry, I'm just thinking of what some of these are. The basement, I don't know. Sure. Weird basement-y thing. Anyways, I can do this as well. Grab a scene import camera here. Now I should have cam 1. And there it is. There's my camera from the scene. And I should be able to move this over here. And I'm going to do a karma node. Drop this down. And the one thing it's angry about here, it's giving me a little warning, is it wants to have my proper camera here. So I'm just going to drag and drop this over here so that I can calculate the resolution of that. And so this is CPU right now. It will work in XPU. I'm going to switch it over to XPU, but I'm not going to talk because I think it's going to freak out my my denoiser that I'm using through my graphics card. So let me just do that, and we'll be quiet for a second. We'll just be nice and quiet. So the reason, hopefully my audio is okay. The reason that took a while to initialize is because it has to obviously compile everything because it's doing it on the GPU. So in some ways, CPU is nice because you get that really quick feedback. maybe for final renders, GPU is a little bit better. Let me just see what this looks like when I move it around and see how quick it renders. That's a 10-second render. I mean, it's not bad. It's not great. I mean, it's got a ton of noise in it, but yeah, 10-second render, not too bad. So yeah, that's how you would do it in XPU. And I mean, obviously you could make a much better scene than what I've come up with here, which is horrible. There was one that I was thinking of. These are all like another language, and I always forget which one's which. There we go. I'll just turn it down. So there we have it. Rendered in XPU. Hopefully that was fun. Not too scary. Just a couple nodes to import it. Import the camera. Assign some materials. Yeah, you're welcome. No worries. Hopefully my audio remained intact through all of that. GPU rendering. Switch this back. Yeah, see, that's the thing that's the thing that the feedback I get about CPU is like, yeah, it's not as fast. I have a 32 core CPU, so I mean that does help. But this render was 16 seconds, right? So it's like, it's slower, yes, but I mean, there's obviously going to be cases where that is way different. But to get that first pixel, CPU can be really nice as well. So it's just something to keep in mind. It like sitting here and doing things interactively, like with the material library, and just seeing like say I wanted to change something like my fire scatter, my fire color to pink, like that is so quick to first pixel, right? Like you're there. Like, yeah, the final render doesn't resolve as quickly, but being able to play around with these colors and just kind of go boom, boom, like you're getting that really fast update speed. And sometimes you have to recompile stuff in XPU or whatever. So just something to keep in mind, that CPU can have its uses as well. And if you're using Material X, you can just switch back and forth and you're all good. Crazy fire. That looks really weird. It's like we put some crazy like copper in it or something. I don't know what makes it green. I think it's copper. Anyways, I think hopefully that will wrap it up for the evening. Not hopefully. I think that'll wrap it up for the evening. If you guys have any questions, I'm certainly interested to help answer them. But if you have any thoughts or last minute questions, I'm happy to answer them. If you are more interested, well, first of all, if you want to connect with us on Discord, the link is at Houdini Hangout. You can grab that, and there's an invite to the Discord server on there. One other thing I actually just was thinking about, since I'm kind of playing with this stuff, if you want to check out something really good, Solaris is Sweet is the name of it. This just came up recently. This is I'll drop this in chat. but this is by a new series by Moeen Saeed, and it is all Solaris based. He walks you through making this whole scene in Solaris and kind of just using all of the fun features that exist in there. It's certainly way more interesting than anything I can do in a couple hours, like live. He's got a lot of stuff in here that's obviously looks really, really nice. I mean, this scene looks great, but yeah, I would highly recommend checking this out if you're interested in like look dev and rendering in Solaris, and you're like, well, I'm just one person. Why should I learn Solaris? Like, this is my answer to it. Like, watch this, understand what's going on in here, and you're gonna find a lot of really cool workflows and uses for Solaris. So that's my answer to it. So check it out if you're interested. But anyways, that will wrap it up for the evening. I think hopefully this is something that's kind of was a big interest of people online. So hopefully this fed that interest for you. And yeah, I'm not sure what next week will bring, but be playing around with some stuff, and I hope to see you then. So thanks a lot for joining, and I will see you all next time. Bye, everybody.